Children, today we are going to see about nitro compounds. Nitro compounds having that is nitro compounds are considered first it is considered as the derivatives of hydrocarbon. Hydrocarbon means already you know compounds containing carbon and hydrogen. So if one of the hydrogen atom of hydrocarbon replaced by NO2 group NO2 group, it is called as a nitro compound. So this nitro compound, that is organic compounds containing NO2 group, that is divided into two types. One is aliphatic nitro compound. The second one is aromatic nitro compounds. Aliphatic, that is CH3NO2, it is called as nitroalkane, nitromethane. So divided into nitroalkanes and CH3ON double bond O. This is called as nitrite, methyl nitrite. So aliphatic divided into two types. Nitroalkanes, it's nitromethane and methyl nitrite and NiTe, nitrite. Similarly, aromatic compounds classified into two, that is benzene ring. Aromatic means consisting of benzene ring with the NO2 group, that is called nitroarenes. Otherwise, one more separation, aryl nitroalkanes. Aryl, that is C6H5 CH2NO2, aryl nitroalkanes. So here this nitroalkanes further divided into primary, secondary, tertiary. Primary means having one alkyl group, that is CH3CHHNO2, carbon satisfied by 4 valency. Secondary means two alkyl groups attached to the functional groups. This is called secondary. Tertiary, three alkyl groups attached to the functional group. Primary, secondary, tertiary. Now these nitroalkanes represented by the formula, that is RNO2, where R is an alkyl group having the CnH2n plus 1 general formula. So nitroalkanes once more divided into primary, secondary and tertiary. Nomenclature, everything clearly given in the book. Next we are going to see about isomerism. Divided into four types: chain isomerism, position isomerism, functional isomerism, a new isomerism called tautomerism. Chain, position, functional, tauto. Now we are going to see about chain isomerism. Consider the general formula C4H9NO2. Now the two ways of writing: 4 carbon NO2 group. Now you have to balance this carbon 2 bond, so 2 hydrogen. This carbon 2 bond, 2 hydrogen. This carbon 2 bond, 2 hydrogen. This carbon only 1 bond, 3 hydrogen. This is called as 1 nitrobutane. The other way of writing, balance it. Carbon 2 bond H2. This carbon 3 bond H. This carbon only 1 bond H3. This carbon only 1 bond H3. 2 methyl 1 nitro propane. 2 methyl 1 nitro propane. Next, position isomerism. So So chain isomerism means they differ in the length of the carbon chain, but same molecular formula. Position also formula C4H9NO2. So position. Now to balance, see this carbon 2 bond, so H2, this carbon 2 bond, so H2, this carbon 2 bond H2, this carbon CH3. 1 nitrobutane. Here this carbon only 1 bond, 3, this carbon 2 bond H2, this carbon 3 bond H, this carbon 1 bond. So 3, 4, 6, 9, C4H9 NO2. Similarly this carbon H3, H3, H3. If you are taking this one, 1, 2, 3, 2 methyl, 2 nitropropane. This is 2 nitropropane. This is 1 nitropropane. Only position of the nitro group changes, but same molecular formula. Next, functional isomerism. Same molecular formula, but exhibit different functional groups. How can you separate this NO2 in different functional groups? I'll write. One nitropropane, the same can be written as butyl nitrite group, nitro group. So, same molecular formula C4H9NO2, same molecular formula but differ in the functional group. The last one is the new isomerism, tautomerism. It is a new type of isomerism, that is primary and secondary nitroalkanes having alpha hydrogen. Alpha hydrogen means the hydrogen the carbon atom having hydrogen next to the functional group. It shows an equilibrium mixture of two tautomers. For example, I am taking nitromethane. This is the functional group. This is the alpha carbon next to the functional group. This is alpha hydrogen next to the functional group. This can be written as CH3 N double bond O2 NO2. This is called nitromethane. Tautomerizes. This is the nitro form. Now in this nitro form, one hydrogen from here, from the alpha carbon, shifted to here. So CH2 double bond NOH NOH. Hydrogen from methyl group shifted to here. So NOHO. This is methyl nitrite. Methyl nitrite. This is aciform because hydrogens shifting from one to another. This is called nitroform. This is called nitroform. This is called aciform. So some differences. Nitroform is less acidic. Aciform is more acidic. And it is also called as pseudoacids or nitronic acids. Number 2, it dissolves in sodium hydroxide slowly. It dissolves in sodium hydroxide instantly, quickly. Decolorizes ferric chloride solution. Decolorizes means changing the color. Here, with ferric chloride gives a reddish brown color. Now, electrical conductivity is low, electrical conductivity is high. These are all given in book page number 199 in second volume. Isomerism, then the introduction part, everything given clearly in page number 199. So, acidic form of nitroalkanes, that is alpha hydrogen atom of 1 and 2 nitroalkanes, show acidic character because of the presence of electron withdrawing effect of NO2 group. So these are more acidic than aldehydes having CHO group, keto having CO group, ester having COOR group, and cyanides having CN group. So nitroalkanes dissolve in NaOH to form a salt, but acid nitro derivatives are more acidic. This is more acidic than the nitro form. So when the number of the alkyl group attached to alpha carbon increases, acidity decreases. When the alkyl group increases, acidity decreases due to plus psi effect of alkyl group. Already I explained this in the last video. What is plus psi effect? What is minus psi effect? Plus psi effect of the alkyl group. So I am giving an example. See here. This is nitromethane. This is nitroethane. This is nitropropane. This is more acidic than this one, because already I told when the number of alkyl group attached to alpha carbon increases, acidity decreases. So this is more acidic, then less, then less. Depending upon the alkyl groups plus psi effect of alkyl groups, the acidity moves on decreasing when more number of alkyl groups are added. Now with the same like this C4H9NO2, I have written many structures: chain isomerism, position isomerism, functional isomerism, tautomerism, same formula C4H9NO2 I have wrote. Similarly, you can try for this compound C2H5NO2, C3H7NO2. These two compounds, for these two compounds you try and write for chain isomerism, or write the isomers. How many possible isomers? How many isomers we can write? You go and check once more by watching this video.